Good morning, geometry class. I hope everybody had a great spring break. I hope everyone had a great time. I know nobody's ready to get back to geometry class, but I'm so glad that we're able to get back and get this next chapter on and get ready to complete this school year. So we're in pace 11:18. So if I believe I have a couple students who still have not picked up their paces. I believe I have two 11:18s here. So if you haven't picked up your pace, you need to make sure you contact me. Come pick that up, okay? Also, make sure your homework is due. Your homework is turned in. That was from last Friday. That's page 5 and 6. The evens need to be completed, so that needs to be in by 3 o'clock today. So I would appreciate that. You get those things in on time. We're going to open up with the word of prayer, and we're going to begin pace 11:18. We're going to do just a brief review. We're going to pick up on page 7 today. We're going to look at areas of parallelograms and areas of triangles. All right, so let's pray, and then we'll get started. Dear Jesus, give us wisdom. We need your help. We ask that you would anoint each student's mind. Myself as the teacher, give me wisdom and alertness, I pray, clarity of thought and clarity of speech, and we'll give you the glory and the honor in Jesus' name, amen. All right, so quickly, 11:18, we did perimeter, and so make sure you want to memorize these formulas. These formulas must be memorized. So we did the perimeter of a rectangle. The perimeter of a rectangle is P equals 2 times the length plus 2 times the width, and then the perimeter of a square is P equals 4 times S. 4 times S. You want to make sure that you know them. Also, we did the area, all right? The area of the square, also the area of a rectangle. The area of a rectangle is area equals base times height, all right? So area equals base times height. That's for a rectangle. And then for a square, area equals the side squared. So perimeter, 2 times the length plus 2 times the width. That is the measurement around a figure, a polygon. For a square, it's 4 times S. The area of a rectangle, again, area equals base times the height. And then the area of a square is area equals S squared. So we learned those things last week. So we're going to continue. We'll score the homework tomorrow. But make sure that your homework is turned in by today, 3 o'clock p.m. All right, so we'll look at page number 7. We're going to look at the area of a parallelogram. Page number 7, the area of a parallelogram. So we see any side of a parallelogram may be a base. The altitude of a parallelogram is a perpendicular line segment from a base to its opposite side. So if we have a parallelogram, and so we have the altitude is a perpendicular line from a segment, so we can go from here to any opposite side, all right, to any opposite side. So even if we went into the middle of a parallelogram here, we would have an altitude, okay, an altitude. So that is called the altitude of a parallelogram. The length of the altitude remains the same regardless of its location in the parallelogram. Again, we could have it here. Also, we could have it to the side extended here, the base, and then we can go down this way. So we have, okay, the altitude. It's the same length regardless of its location inside the parallelogram. Now, notice the shape here. We have parallelogram A, B, C, D. Okay, parallelogram A, B, C, D. Now, if I were to take this altitude here, we're going to extend it. All right, we're going to go right down here. Notice EC, line segment EC. Okay, this is our altitude. We have a triangle that is formed. Okay, a triangle that is formed. And so, what if? All right. So, what if I take this triangle, okay, and I put it over this side of the parallelogram? What shape would I get? So if I were to extend, okay, this side here, and then we were to come down to here, okay, and we're going to call this, all right, we'll call this, all right, we're going to bring it over here, so now we'll call this FD. So I'm taking this triangle here, I'm flipping it over here, so I'm going to remove that. What shape do we have? We have a rectangle. Very good. A rectangle has 4 right angles. Now, since the area of a parallelogram is equal to the area of a rectangle, a parallelogram uses the same formula. So to find the area of a parallelogram is the same exact formula to find the area of a rectangle. So we can kill two birds with one stone there. The area of a parallelogram is area equals base times the height. The base times the height. So you make sure that's theorem 99. You want to highlight that formula. Area equals the length of the base, the product of the length of the base and the length of the altitude, the length of the height. Let's turn to page number 9. You'll see a proof there, but on page number 8, we're not going to do that. We're going to skip that. That really doesn't have any bearing on what we're going to be doing now. So we're going to skip that, and let's work on practice on some of these on page number 9 in your textbook there. Look at number 5, okay? Look at number 5. Okay, I'm going to erase this. Okay. All right, we have a parallelogram here. Okay, notice the altitude. Okay, we have the altitude is 0.5 meters. And we have the base is 1.25 meters, okay? And then for number 6, all right, we have the altitude is 2 square root of 2, and the base is the square root of 8. Okay, so let's quickly work these two out together, and then we'll go through this page. Number 5, we're going to work on this together, okay? So what is the area of this parallelogram? Well, simply, again, it's the length of the base, the product of the length of the base and the length of the altitude. So we're going to simply go area equals, I always like to write my formula first. It gets me in the habit of memorizing and gets me in the habit of knowing these. So area equals base times the height. So 1.25 meters, that's our base, times our altitude, which is our height, 0.5 meters. Just get your calculator out, do simply 1.25 times 0.5, and we should have the answer 0.63 meters squared. Now remember, make sure your units are done correctly. Since we're doing altitude, the answer is always in square units, all right? So 0.63 meters squared. Now let's jump down here. Now we have a rectangle. Since a parallelogram, right, is the same formula, the area of a parallelogram is the same for area of a rectangle, we're going to go area equals base times height. Area equals, the base is the square root of 8 meters times the square root of 2 meters. Since we can multiply these numbers inside the radical, so 8 times 2 is 16 meters squared. And then just simply find the square root of 16 meters squared. The square root of 16 is what? Joe, how about we follow up with Hemi? Very good. 4 meters. 4 meters. And that would be the correct answer. Sorry, this would not be meters squared. I'm sorry. This would be 16 meters and then squared. I'm sorry. And then 4 meters squared there. That would be the correct answer. So parallelogram, rectangle. All right, so what I want you to do, we're going to do some of the odds on this page. I want you to do the evens for homework. So page number 9, evens for homework. So let's go through and let's just do a couple. Make sure we're all on the same page. Again, if you have any questions, you may contact me and we'll be able to work through these together. Look at number 7 here, okay? Using area equals base times height, find the unknown lengths, okay? So look at number 7. We have area equals 6 meters squared. So now they're giving us the area. So 6 meters squared is equal to, all right, the base and the height. So we don't know what the base is, and the height is 2.5 meters, okay? Again, all we need to make sure in order to solve this, as long as we have 2 out of the 3 elements, we can solve any equation. So, all right, we have 2.5 times b would be 2.5 meters b. This would be 6 meters squared. All right, now all we want to do is we got to get the letter b by itself. So I'm going to divide both sides by 2.5 meters. Okay, 2.5 cancels out. So what is the base? 6 meters squared divided by 2.5. So 6 divided by 2.5 is 2.4. And then what we want to do here for this one is, okay, since we have meters, 2 meters up here, we have 1 down here. So we're going to cross out one of those meters, all right, there. And then we just simply have 2.4 meters. If you want to check that, you just simply take 2.4, plug it back up into here. So 2.4 times 2.5, and that gives me 6 meters squared, okay? So let's look at number 9, all right? Number 9, we have area is 10 centimeters squared is equal to, all right, again, looking for the height. So we have 0.5 centimeters, and we're looking for, excuse me, the height. If you write altitude, if you write A for H, they are interchangeable, okay? So simply, all right, so we're going to multiply here. So we have 0.5 centimeters is our height, 10 centimeters squared. We simply want to divide both sides by 0.5 centimeters. All right, get your calculator out. 10 centimeters divided by 0.5 centimeters. We have, what do we have, class? Good. We have, remember, one of these cancels out. And our answer, our final answer is going to be 20 centimeters. 20 centimeters. Again, if you like to check it, put 20 times 0.5, and we get 10 centimeters is our answer. All right, let's look at number 11. Number 11. Okay, number 11, we have area is 15.5 kilometers squared. No, that's sloppy. Hold on. 15.5 kilometers squared is equal to, all right, we have our base, which is 2 kilometers. And then we're looking for our height, all right? So again, simply multiplying our variable and our coefficient here. So we have 2 kilometers, our height, 15.5 kilometers squared. Divide both sides by 2 kilometers. H equals, again, we have 1 kilometer here, 1 kilometer here, which leaves 1 kilometer in our answer. So 15.5 divided by 2 would be 7.75. 7.75 kilometers is your correct answer. All right, so let's do a couple more down word problems, and just practicing. We're just getting used to finding the area of a parallelogram. Okay, let's look at number 13, and then we'll do number 15. 13 and 15 on page number 9. Okay, so 13. The base of a parallelogram is 9 centimeters, and the altitude is 6 centimeters. What is the area of the parallelogram? So again, area equals base times height. So just want to plug and chug here. So the base is 9 centimeters. The height is, altitude is 6 centimeters. Simply, hopefully you don't need a calculator. Do 9 times 6. We have 54 centimeters squared. Be sure, again, be careful with your units, making sure that you're putting your units in the answer, right? So they are square units. All right, let's look at number 15. We have 2 adjacent sides of a parallelogram are 8 centimeters and 12 centimeters respectively, and they form an angle measuring 60. Find the area of the parallelogram. All right, so we have, all right, let me draw this out. Okay, so we have, let me read this again. We have 2 adjacent sides of a parallelogram. So remember the definition of adjacent. The definition of adjacent would be a common side, common vertex. So 2 adjacent sides. So we're going to go, right? Would you agree that would be, right, the adjacent side be here? Okay, so obviously we're having a parallelogram, so I'm just going to extend that sides. Okay, So we have the two adjacent sides of a parallelogram are 8 centimeters and 12 centimeters. So let's go 12 centimeters. We'll go 8 centimeters, okay? Now the question is this, all right? They form an angle measuring 60 degrees. Find the area of a parallelogram. Find the area of a parallelogram. All right, so now, what do I need to do here? Okay, what we need to do is we need to form, okay, let's pay attention here. Let's read the question again. Find the area. So in order to find the area, we need to have what element in our equation? We need to have the height or the altitude. Very good. So if I am going to draw an altitude here, okay, we have, remember, the altitude is always a perpendicular line which forms a right angle. Now, class, how do I find the side of a right triangle? Does anyone remember how to find the side of a right triangle here? Okay, now since this is 60 degrees, we learned this last pace 11-17. What kind of right triangle do we have here? A 30-60 right triangle. You got to remember from the last page, that was a highlight. A 30-60 right triangle. So if this is a 30-60 right triangle, does anyone remember how to find the length of the sides? All right, so we have, remember, to find the hypotenuse, it's C equals 2 times A. And then B, right, is the square root of 3. So now let's find the length of this side. Once I find the altitude, it's area equals base times height. So let's figure this out here, okay? So we know what the hypotenuse is. If this is the right angle, this is the hypotenuse. So 8 centimeters equals 2A. Divide both sides by 2. And A equals 8 centimeters divided by 2 centimeters is 4 centimeters, okay? Now, we know that is 4 centimeters. Okay, now, let's find what the hypotenuse is, or the side B. So, all right, the altitude is A to the square root of 3. So, all we're going to simply do here, since A is 4, right? So, the second side would be 4 to the square root of 3. Now, that's just the first step. Since now that we've learned how to use the 30-60 right triangle, now I'm going to take that, now I can do the base times the height. Area equals base times height. Now, okay, so the base is, we know, class, all right, the base is 12 centimeters, and the altitude is 4 to the square root of 3. Multiply that. Now we're going to take this. Does anyone remember how to multiply it? Let's put here centimeters. Okay. All right. We can multiply our whole numbers. So 12 times 4 is 48. Very good. We have centimeters squared. And then it would be 48 to the square root of, let me actually write my square root first. And then we'll go our units. It's 48 to the square root of 3 centimeters squared. Now our directions say make sure that we use a calculator with the square root function. We do not want to leave anything in the radical sign. So simply get your calculator, find the square root of 3, times that by 48, and then you want to round off the 2 decimal places. So our final answer would be 83.14 centimeters squared. So this is a perfect illustration of how something from our last pace, okay, applying to this pace. So let's quickly review then for the last pace. All right, we've defined the sides of a right triangle. We used the Pythagorean theorem. C squared equals A squared plus B squared. If it's a special case of a right triangle, the 30-60, the hypotenuse C equals 2 times A, and then the length at side B would be A times the square root of 3. And then the isosceles right triangle, which is simply A times the square root of 2. All right, so making sure you understand, taking those from the previous pace and bringing them along with us. All right, let's look at page number 10. All right, so we have now the area of a parallelogram. Now let's quickly look at the area of a triangle, and then we'll finish for this morning. So area of, rectangle, area of a parallelogram, area equals base times height, area of a square, s squared. Now page number 10. Look at page number 10 here. Okay, the area of a triangle. You need to know the length of the altitude and the length of the base to find the area of a triangle. So two elements we need to know in order to find the area of a triangle. The length of the altitude and the length of the base. You need those two factors in order to find the area of any triangle. The altitude of a triangle is perpendicular. Read the definition with me to top of page number 10. The altitude of a triangle is a perpendicular from any vertex to the opposite side or the opposite side extended. So, quickly here. If you look inside your book here, all right, we have triangle A, C, B. Again, a perpendicular from a vertex to the opposite side of the triangle would be considered the altitude. Okay? All right, so if I have a right triangle here, call this A, B, C. All right, so AB would be my altitude. And then if I had a triangle like this, so any vertex to even the side extended, all right, we call this A, B, C. All right, so even here, again, we have our altitude. So no matter where the location is, the altitude is always the same length. It's always the same length. Now, look at the Theorem 100. Again, this is a simple highlight. Need to make sure that you're memorizing these formulas. The area of a triangle would simply be area equals 1/2 the base times the height. 1/2 the base times the height. Let me show you how we come up with that formula, because quickly, if I were to take this 1/2 out of here, what does that formula look like? Very good. It's the same as the rectangle. It's the same as the parallelogram. So what is the relation then? Where does this 1/2 come from? So let me draw a parallelogram. Okay. We're going to call this parallelogram A, B, C, D. Now, does anyone remember what that line is called? Gabe, what is that line called? And then we'll have Fausto follow up. What is this line called here? A diagonal. Very good. And what does a diagonal do? Katie Strzelecki, then have Gianna follow up. What does a diagonal do to a parallelogram? Good. It divides a parallelogram into two congruent triangles. Two congruent triangles. So we could say this, that a diagonal divides a parallelogram in half. In half. So where does this 1/2 come from? So it comes from the idea of this diagonal dividing a triangle into 1/2. So simply if I drew my altitude, all right, well, that's our altitude there. All right, so in order to find the area of this triangle, we would simply go 1/2 times the base times the height. 1/2 times the base times the height. All right, so let's turn the page. We'll quickly practice a couple of these, and then we'll finish off for this morning. So the area of a triangle is 1/2 times the base times the height. Now, going back to last pace again. I know you guys hate when I do this. Going back to pace 1117, there are two special cases of right triangles. There's the what? What do we have? How about Hannah? You give me it, and then we'll have Chris Rob follow up. The two special cases of right triangles are? Good. The 30-60 right triangle and the isosceles right triangle. So then we have to, all right, manipulate. If it's just an ordinary right triangle, we use area equals 1/2 the base times the height. If we're going to use a 30-60 right triangle, so here we're going to have to know this. Area is equal to, all right, we're going to call this an equilateral triangle. And obviously, since an equilateral triangle, it's 60 degrees, right? Let me just quickly explain that. Okay, if we have an equilateral triangle, all three sides are congruent. An equilateral triangle is also equiangular, so that would mean 60, 60, and 60, correct? Now, what if I drew an altitude perpendicular, so from any vertex to the opposite side? Now, this is also an angle bisector. So this perpendicular here, this altitude, divides this angle now into two congruent parts. So if I have an equilateral triangle or an equiangular triangle, notice it's the 30-60 right triangle. So how do I find the area? So here's the formula. You'll find this on the bottom of page 11. So the area is equal to S side squared times the square root of 3 over 4. That's if we have a equilateral or equiangular triangle. So again, the special cases, you need to pay attention to what kind of triangle you are getting, all right? So let's say that this equilateral triangle, let me draw another one. Okay, so let's say we have a triangle here that each side is 8 meters, okay? So find the area of this equilateral triangle. So we're going to use this case here. So we're going to go area is equal to, all right, what's the side? S is always standing for the side, so 8 meters squared. 8 meters squared times the square root of 3 over 4. Once we plug and chug, this is the easy part here. So 8 times 8 is 64 meters squared. There's the square root of 3 over 4. And then what we want to do is we can reduce 4 into 64. So 4 goes into 64, 4 goes into 4 once, 4 goes into 64. So 16 to the square root of 3 meters squared. Now, depending on what the directions say, either leave the radical in simplest form or simply use your square root function and you can simplify that radical and then round off your answers to 2 decimal places. So let's close at page number 12. Page number 12, we're going to do just a couple on page 12 and a couple on page 13 just to make sure that you understand what you're doing. And then for homework, you're going to complete these pages and be prepared for your quiz tomorrow. All right, so that'll be the checkup on page 14 and 15. So let's just do a couple just to make sure we know what we're doing. And then you can do the rest. Number 12, let's look at number 5. We'll do 5, 7, and 9. And then we'll do a couple on page 13. All right, so look at number 5. Okay, all right, here's our altitude. So we have, this is 7 meters. This is 9 meters. Okay, so number 5, find the area of these triangles. Make sure you round off answers to 2 decimal places. You may need a separate sheet of paper, obviously, or at least you do it neatly on your page here. Okay, so number 5. All right, so area. Now, we're not saying that this is an equilateral triangle, so we're just going to simply go area equals 1/2 times the base, which is 9 meters, and the height, which is 7 meters. So 1/2 times, okay, 9 times 7 would be 63 meters squared, and then simply 0.5 times 63, very good. We should have 31.5 meters squared. 31.5 meters squared, okay? Again, make sure you have your units there. Make sure you round off to 2 decimal places. All right, let's look at number 7. Number 7, all right, number 7. I believe that is, let's see here, what triangle is that? Okay, all right, I'm trying to figure out here, number 7. There's 2 triangles and 3 problems. So I think that's for right above it, all right? So let's look at that one. All right, so we have, okay, triangle here. All right, we get our altitude drawn, and then our altitude is 4 centimeters, and our base is 7 centimeters. Okay, and I think that's not the right column. Okay, the triangle right below. I'm sorry, not the triangle right above. It's the triangle right below. Okay, so we have. Let's do this again. All right, so we have the side extended. So we're going to have, this is 0.7 centimeters, this is 1.1 centimeters. All right, so let's get our calculators. All right, 1/2. Area equals 1/2 times the base, which is 1.1 centimeters, times 0.7 centimeters. Okay, so, all right, class, get your calculator out. 1.1 times 0.7 simply is, right, 0.77 centimeters squared, and then times that by 1/2. So 1/2 times 0.77 simply is 0.39 centimeters squared. 0.39 centimeters squared. All right, let's look at number 9, and we'll move on. Okay, number 9. All right, we have our altitude again, it's perpendicular, and we have, this is 9 millimeters, and we have 11.5 millimeters. Again, all right, so this is not a special case, we're just simply going with area equals 1/2 times the base times the height. So for 1/2 times the base times the height, okay, 1/2 times the base, which is 11.5 millimeters, times the height, which is 9 millimeters. 1/2 times, again, get your calculator out, 11.5 times 9 millimeter is 103.5 millimeters squared. All right, get your calculator out, times 0.5, 103.5 times 0.5 is 51.75 millimeters squared. All right, I don't know if you have any questions, but pretty straightforward, pretty simple. Let's just do a couple problems on the back end here. We'll do 11, and then we're going to do a couple special cases. I want to see how you do a couple of special cases with the equilateral triangle, all right? So again, just so I'm clear, page number 12, you want to make sure you do the evens for homework, page number 12 for homework. All right, let's look at number 11. Number 11, we're given the area. We want to find the height. Okay, so 1/2 times base times height. Okay, so we're given the area here. So the area in number 11 is 8 centimeters squared, and we're going to go 1/2, and then let's see what's given to us. The base is 6 centimeters, and we want to solve for the height. We want to solve for the height for number 11. So, all right, let's quickly multiply 6 times h, right? So 8 centimeters squared. I'm going to do this a little longhand so everybody can see the steps as we go through. So 1/2 times 6 centimeters h. Okay, again, we want to simplify these parentheses here. So 8 centimeters squared equals 3. Okay, now how do I get h by itself? Real simple. No matter which elements or characteristics of the equation we have, at least we have 2. We can always solve for the third variable. So divide both sides by 3 centimeters. So h equals, what's the altitude? If the area is 8 and the base is 6, get your calculator out. 8 simply divided by 3 is, again, round off the 2 decimal places. We have, all right, our units. 1 cancels out there, 1 cancels out there. So I'm left with 1. So the answer is 2.67 centimeters in height. 2.67 meters in height. So I want you to do 12, 14, and 16 there. 12, 14, and 16 on your own. And then let's look at, I just want to look at 2 more special cases here. let's look at number, trying to figure out, let's do 19. All right, let's do number 19. And we'll go down and do number 24, all right? 19 and 24, we'll do those two and we'll close. That's what we want to make sure. We want to just do special case so you see how that goes. All right, look at number 19. Find the area of an isosceles triangle if the base is 12 millimeters and the equal sides are 10 millimeters. Notice the hint. Use the Pythagorean theorem to find the altitude. So, okay, we have an isosceles triangle. All right, we have a base of 12 millimeters, and then we have a sides of 10. Okay, let's draw our altitude here. Now notice what we have. We have a right triangle that's formed. A right triangle that's formed. The question is simply this. Find the area of an isosceles triangle. Again, use the Pythagorean theorem to find the altitude. So the Pythagorean theorem, class, remember? Okay, we want to find, all right, so we want to find the altitude here. So if this is the right angle, what side of the right triangle is that, class? What side is always opposite the right angle? The hypotenuse. Very good. So we have 10 millimeters squared equals, all right, let's say we're going to solve for a squared plus, and then 10 millimeters, we're going to go, all right, or the base is 12 millimeters, excuse me, squared, okay? Let's quickly solve. So we have 10 millimeters squared. That's going to be 100. So 100 millimeters squared is equal to a squared plus, and then 12 times 12 is, very good. Oh, made a mistake here. Remember, we have, if this whole length here is 12, then this side must be 6. Made a mistake there. All right, so, and you're all like this. Yeah, that's right, that's right. Don't follow. You better make sure you follow the rules. Okay, that's 6. So that would be 36 millimeters squared. All right, now let's get A by itself, class. So simply, what do we need to apply to get A by itself? Very good, the subtraction axiom of equality. So we're going to multiply both sides by 36 millimeters. That cancels out. So A squared is equal to 100 minus 36 is simply going to be 64 millimeters squared. Now all I want to do here is we got to remove this exponent. Does anyone remember how to remove the exponent? Find the square root of both sides. So A is equal to, and the square root of 64 is 8. Right? 8 millimeters. Now, that's not the answer. That only gives us the altitude. Now, how do I find the area? Area equals 1/2 base times the height. 1/2 the base of the triangle, which is 12 millimeters, times the height of the triangle, which is 8 millimeters. So 1/2, okay? 12 times 8 is going to be 96 millimeters squared, and then we're going to simply multiply that by 1/2, and we have 48 millimeters squared. So again, applying what we learned last pace, bringing it with us in this pace. And so what I want you to do, again, just to be clear for homework, I want you to finish page number 9. Page 9, I want you to finish the evens, and then I want you to go to page number 12. I want you to do the evens, 6, 8, and 10, and then page number 13. I want you to do 12, 14, 16, and then on the bottom part, I want you to do 18, 20, and 22. All right, so make sure you get that in, and that makes to be turned in by 3 p.m. tomorrow. All right, so also be ready for the quiz on Wednesday as well. All right, so have a blessed day, and hopefully we'll see you again tomorrow.